Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC, we do everything DIY. And today we have a service call for an LG multi-V unit. Thank you to everyone tuning into Jumperman Tech. It's a nice chilly day in New York City. We got a service call for a multi-V unit. This is a new spot for me. It's my first time working on one of these. Let's see what we can do. Let's get started. There's nothing happening here. Let's just open up the covers. Let me see what we're even working with. This is quite the machine. This thing is no joke. All right, so I know this is our main controller. Let's pay attention to what that says. Got a C1 and N1, and then 291. C1 1. C1 I think actually stands for compressor. I was researching these. Let me see how many compressors are here. Just one. We only got one compressor here. Let's see what's going on. All right, so I'm using one of LG's apps. So the C1 is compressor 1 or inverter 1. Okay, there's only one circuit here, so that's good. So it's got to be that. And we got a 291 error code, but when I plug it in into here, it's just 29, just the first two numbers. That's what it seemed to be like when you plug in these errors. That's what it is. So it's saying outdoor unit inverter compressor overcurrent. So the compressor, it sensed that there was too much current, too many amps were drawn, and I guess it shut down on that error. Then it says cause of error, outdoor unit inverter compressor fault or drive fault. So this is an inverter compressor, runs off DC voltage, and it modulates because we can do different speeds according to demand. So we either got a faulty compressor or we actually have a bad inverter board, because pretty much the inverter board is what's generating that DC voltage for that compressor. So if something went wrong here, it could have caused the feedback to the compressor. This is just my, train of thought at the moment. So we got the unit downstairs running, calling for cooling. Fan is blowing, nothing's happening, no error codes, but when we come up here, we saw this. So the first thing that I'm gonna wanna check is really that compressor. Is that compressor fried or not? This is a Megameter. This is made by Subco. It's probably the most affordable one you can find, and definitely the easiest one you can use. And let's start by turning off the power for this unit, and then disconnecting the wires at the compressor and checking the compressor itself in mega ohms. So my power coming in, I see this whip right here goes into that, but this is like communication wires that goes to the branch box, and then it gets distributed from there. This is our power wires. From there goes into one of these boxes right here. Okay, disconnect. Let's see if I can shut that one off. I don't want to take off those gates there. It's one of these. You got to be real careful. You don't want to fall off the side of the roof here. And definitely not. So hold up. It's that one. That's the disconnect. All right, got that off. We want everything to de-energize there, so we're gonna wait about 3 to 5 minutes, make sure we don't get electrocuted or fall off this roof, and then we can begin our checks. All right, so the lights did turn off. You always want to double check your power. Nothing, good. It's ground, 0 volts AC. Cool. Difficult to get in here because of all this wiring, but I just took this cover off. We have 3 terminals, right? Those 3 wires right there. We got a yellow, black, yellow, blue, and red. We're gonna want to make sure exactly which each termination goes. I saw in some area people are checking the resistance and everything with the wires on it. I never do that. I always isolate and then check, because there could be an issue with the wiring. So I want to check the compressor on its own. Hope you guys can see in the video here. So I took a quick picture so I know exactly where that goes. So I want to isolate the compressor. Careful not to lose it. The hardware. Little washer and bolt. I don't really have a good place to grab with my meter. Got little alligator clips on the edge of it. So what I'm gonna do is actually put the screws back on without the wires, just so I have something to catch. And that's how we're gonna check this compressor. So I have one connected to one terminal and the other one to the casing of the motor. You do want that casing to be away from the paint, because that could throw you off. There is paint right now, but let's just see if we can get any sort of reading. It started at 150 and it went above, so that terminal checks out. Check the next one. It's just on, so that was above the 1000 ohms. The other one started off low. Could be a potential issue there. These are super sensitive. And the other one starting at 150 then goes up, so it's getting close to that 100 meg ohms to where there could be a caution. These things are very sensitive, so that could throw you off. So as far as this, let me sand down that shaft, excuse me, the casing of the motor, so I get a better reading and so I can really confirm this. All right, so we sanded it down and double checked, and pretty much we're getting the same readings. The only thing that bothers me is that usually when it's like a new compressor or something's good, as soon as you press the button, it just says on. It says above, you know, 1000 meg ohms, there's no light, it just says on. But when I press it, it starts at 150, and I did work on a Daikin system before where I read 100 meg ohms, and technically that's on the border of good and caution. It still should operate. That's what was tripping the system, and I had to replace it. So considering that it's starting at 150, might be a little indication that there might be something wrong there, but this is not the best mega meter. Honestly, I wish I had something better at the moment. So after that, we could have an issue with the inverter PCB, and honestly, if you just change the compressor with the inverter, probably be good. Thing is, this PCB is like back here somewhere. I mean, I took off this panel, it's kind of hanging off these wires right now, but how am I supposed to test that right now exactly? I've got to check DC voltage on that somehow. I double checked my meter and I only had 366 volts DC coming out of here. It's supposed to produce 500 volts DC. Just replaced the batteries, got new sets of batteries, and we're gonna double check this reading, and I am getting a different reading. Look at that. Bad. We got one terminal to the compressor, the other one to the casing of the motor, and it is sanded down. We're gonna go off to the next one. These are very sensitive compressors. Even the caution will send you out. Bad. And then the third one. Bad. See where it stops off at. Yeah, right at that caution area. Considering it's like that, this thing is done. Okay, so we got a bad compressor. That's one. They also want you to double check the inverter board, converter board, and the diode on here. I'm already gonna condemn the compressor, and typically what's a good rule of thumb, I know a lot of guys do, at least from what I heard, is that when you change the compressor, you change the inverter board together. I called tech support, and we need a meter that reads diodes, so I went and grabbed one. And pretty much it could be, this is the converter board, could be an issue with the converter board. Right under it is the inverter board, the compressor, or also the diode that's in the converter board, which could be replaced separately. So we got to do a couple readings on that. Tech support guys sent me an email with some checks, so let's go ahead and see what we can find. Don't see any other way to do this. I disconnected these 3 wires just so I can get a peek in there. I took off this cable. This is the converter board. Over here we have 11 terminals, and pretty much you want to check between 10 and 9 and then 11 and 9 and check resistance. So let's try that. They want us to do that for the converter board and the inverter board, but let's do one at a time. So let's see what we get. Let's check between ground, the black wire, and the first one. Supposed to read above 1K ohms. Alright, we got about 6.4 kilo ohms. That's good. And this one's supposed to read above 10 kilo ohms. Let's see if we get a good reading. Alright, 50 kilo ohms rising. It's gonna go to OL probably. Yeah, after 65 kilo ohms it goes to OL. So we did get above the readings. That's that. And then the converter board, the inverter board, you take off this one. Terminals 4 and 5 is ground, 6 is 5 volts, 7 is 15 volts. I'm gonna show you guys a diagram with that as well so you guys can see exactly what I'm doing. Let's check between these now. It's ridiculous working like this. It's got to be another way, but it is what it is. All right, let's see what this is. We're getting ohms, not kilo ohms. Let's reset this. I want to make sure. So that's 2,500 something ohms, no kilo ohms. Let's go between 4. Excuse me. 4 and 5 is ground, so either one of those, and then 7. See, this one's coming down. That's definitely not right. 924 ohms. 924 ohms. Hold on, here's the... Now we're going back down to ohms too. This is between 5 and 6. So 2,500 ohms between 5 and 6, and then 5 and 7. Let's see where it comes out to. Yeah, this looks like it's stopping about 924. All right. Between ground. Okay, so between ground and the 5V, we should be above 1 kilo ohm. And then between ground and the 15V, we should be above 10 kilo ohms. But we got a reading in ohms. All right, so right now, this compressor is bad. And I have an abnormal reading as far as right here for the inverter board. Next, we're gonna check the diodes. So the IGBTM, we're gonna put the black lead on P and then check UVW, and then we're gonna put the black lead, then we're gonna put the red lead on N and then check UVW. And this is for the inverter. So let's start with the first one. Let's put on positive UVW, and pretty much any diode you check has to be between 0.38 to 0.7. Anything out of range is no good. So let's start it. P to UVW, so the black one to P. Positive is this one, and then it is the UVW, so 0.41, 0.41, 0.41. That's in range. We put the black to P, and then we checked UVW with red. Now the next thing we're gonna do is we're gonna put the red to neutral and then check UVW with black. So red to neutral, which is gonna be this one instead of that one. And now let's check. 0.41, 0.41, 0.41. Everything is 0.415, so we're in range of 0.38 and 0.7, but we were out of range for as far as resistance, so I would still condemn this board. As far as right now, new compressor with new inverter board, very common that you change both of those together. As far as what I hear, honestly don't work on these much. And then just to be sure, I want to check the diode for the converter board itself. Here's the converter board, and here's the diode there. You're gonna see a positive, negative, and then RST. So what we want to do is we got to do two tests. The first one, we're gonna put the black on P and check RST. Black on P and then RST. We gotta be in the same range as the other one, between 0.38 and 0.7. We got 0.49, 0.49, and 0.49. So between P and R, and then P and S, P and T. Then we're gonna have to switch that, so that's in range. So then we're gonna put the red on N. Put the red on N, and then check all those, or check TSR again, or RST, whatever. 0.485, 0.49, 0.49. All right, there's nothing wrong with that diode on the converter board. And we also checked this over here, the resistance. So this converter board is good. The diode is good. So we're pretty much down to the inverter board and the compressor. And that's most likely the whole issue here. We got all the meters on the job today. All right, so pretty much we already know the deal. We got that error code, compressor over current. Not uncommon that the compressor went bad, and then the inverter board, because the compressor goes directly pretty much to the inverter board. That's what's sending the DC voltage down there. So that could have got messed up and trickled back to the compressor. But we're gonna leave this video here. The idea here is gonna be to take the model number of this unit and call tech support or the manufacturer. It's impossible to get part numbers out here, so wherever I can get the part number, I'll get it based off the model number. But just in case, I did take some information off the board, and I did take the information off the compressor itself. So the next visit, we're gonna change the compressor with the inverter board. Hope this thing doesn't blow up. So that's pretty much it with this video. We're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.